All right, today we're going to be studying two more types of quadrilaterals. So we're going to get away from the parallelograms that we've been focusing on and go back to quadrilaterals, which are just four-sided shapes. The two shapes we're going to be looking at today are the trapezoid and the kite. So the first up is a trapezoid. A trapezoid is a quadrilateral with one set of parallel sides. So you're looking at this picture here. With parallelograms, they had two opposite sides were both parallel. Now this one, they're clearly not parallel. We know in this picture that BC is going to be parallel with AD. If we look at AB and CD, all right, they are definitely not parallel. If we extend those, they're definitely going to run into each other at some point. Here are some other properties. So since those are parallel, we've got some other things that we can kind of look at. Another property is if we do the measurement of angle A plus the measurement of angle B. All right, those are consecutive or same side interior angles, which means they would equal 180. And the same would go for the measurement of angle C plus the measurement of angle D. Those would also equal 180 because they're consecutive interior angles. Here are some kind of like vocab words for you guys for a trapezoid. So this is what we call a base. And this is also a base. So it'll have two bases, and those are the base are going to be the parallel sides. We call AB, this would be a leg, and CD would also be a leg. Okay, so your parallel sides are going to be your bases. We also have what we call a mid-segment. Now the mid-segment you will have to draw in yourself, kind of like we did with the diagonals. So a mid-segment, it's a segment that connects the midpoints of the two legs. All right, so if I draw this in here, the mid-segment is going to connect this midpoint right here. So this would be the same as this. And this midpoint over here. And it's going to connect those 2 points. Okay? And that is what we call the mid-segment. Now the good thing is we can actually figure out how long the mid-segment is based on the bases. So the mid-segment is actually an average of the two bases. Average of two bases. So let's do this little example down here for us. All right, it says that we have one base that is 12. We have one base that is 20. And we need to find the mid-segment. So how you do that is you're going to do base plus base divided by 2, and that'll equal your mid-segment. So my first base is 12 plus my other base is 20 divided by 2 will equal my mid-segment. 12 plus 20 is 32. 32 divided by 2 is 16. So my mid-segment is 16. So that's what that will kind of look like there. Excuse me. All right, we also have what we call an isosceles trapezoid. So this is a special type of trapezoid. It is a trapezoid with two congruent legs. So the legs are going to be equal here. So I can say that AB is the same length as CD. It's still a trapezoid, so we still know that BC, that base, is going to be parallel with AD. That won't change. Some other things we can kind of talk about here, because it's an isosceles trapezoid, there's a few more extra properties here. Your base angles are going to be congruent. So what that means is like the measurement of angle A, that base angle, and the measurement of angle D are going to be equal. So this base, and why those two are going together, because if you notice they're both on that same base of AD. whereas the measurement of angle B would be equal to the measurement of angle C. So this angle and this angle, because they're on that same base there. Another thing about this, another property, is that their diagonals are congruent. So AC is going to be the exact same length as BD. Now, if you notice, they are not bisect each other, so we cannot say that like AD or BD is getting cut in half. All right, but the actual diagonals themselves are congruent. And we saw the other same properties. We still know that like A and B would add up to 180, C and D would add up to 180, so on and so forth. So here's a little example in here of our trapezoid. So this is going to be an isosceles trapezoid. I know that because of these markings right here, which means that we're going to have our two bases. This is one base, and this is our second base, which means our base angles are going to be the same. So this one is 40, which means my angle over here is also going to be 40. If I wanted to find these two top angles here, remember that these two angles, this 40 and the angle up here, are consecutive into, which means they'd add up to 180. So I can do 180 minus 40, and I'd get 140. Since they're base angles, 140 would also go here. Our last one here, our last shape, is going to be the kite. So the kite is a quadrilateral with two pairs of congruent sides. So same thing, this is not a parallelogram. The opposite sides are not parallel, all right? But we know that AB is going to be congruent to BC, so the two sides that are connecting at that vertex, and AD is going to be the same as DC. Here are some other properties we can make about this kite here. We know that the diagonals are going to be perpendicular. So if I draw on my diagonals, I know that they create 90-degree angles. We know that one pair of opposite angles are congruent. All right, so if you look at this shape here, what we've pretty much got going on is that we have two sets of congruent triangles. We know that triangle AB over here, and whatever this point is, and this triangle are going to be congruent. They're going to be the exact same, which means that this angle and this angle are going to be congruent. And this angle and this angle are going to be congruent. However, we also have these two congruent triangles down here, which will show us that this angle and this angle are going to be the same, and these two angles are going to be the same. So you can notice here, not all of our angles are being cut in half. The only angles that are being cut in half are angle B is being bisected and angle D is being bisected, because on either side of that diagonal, they're the exact same measurement. A and C don't have the same measurements. So one pair of opposite angles are going to be congruent, and then our instance here, that's going to be angle B, or congruent, my bad. Oops. I meant to say here, one pair also are going to be bisected. So one pair of those opposite angles are going to be bisected. So B and D are bisected. They're cut in half. They do not mean that they're the exact same measurement. But if you look up here as well, if you look at angles A and C, see how they both have an orange and a green going on there, which means they'd be the exact same measurement. So angles A and C are congruent. So only one pair of opposite angles are going to be congruent. And also the very last information here is only one of the diagonals is going to be bisected. One diagonal is bisected. So you look at this picture here, this and this would be the exact same measurement because they're in that purple triangle there and the green triangle, all right? But if you look at this one, from B to this point and this point to D, they are not the same length, all right? So that diagonal is not being cut in half. All right, so here are some examples that we can do with the kite. I'm gonna redraw this picture down here. Okay, if I know, and usually we're gonna have diagonals drawn into the kites, or we can draw them in ourselves. If I know that the measurement of angle A is 130, okay, and let's tell us that they tell us this angle is 30. We should be able to kind of figure out all the other angles from here. Now we know that these will be 90 degrees. We also know, since these two top triangles are going to be congruent, that if this is 30, this is also 30. If we know that angle A right here is going to be 130 degrees, we can find this part of it because it's part of that little triangle. So we can do 180 minus 90 minus 30 and get 60. And since that whole angle is going to be 130, I can do 130 minus 60 and get 70. And since these two top triangles are congruent, that means that this angle is also 60, which means this angle is 70. And I can repeat the process to figure out what this angle down here would be. If I do 180 minus 90 minus 70, I get 20, which means this is 20. We also know that this is going to be the same as this. These two sides are going to be congruent, and these two sides